so I can bring it up?
Pulling that up. Hang on just one second. Ah, I'm looking. So here's what I've got. So I've got it on my phone, and then it's broadcasting to my big screen TV.
Okay.
So let
Show
me
me
just
one of this.
hang
I
on. Let
can
me.
tell what it is by looking at it.
Okay, it's Arriba Terra.
Arabia Terra.
Arabia Terra.
And it's called Arabia Terra because it looks like Saudi Arabia.
Understand. Right.
So, do you want to watch it from mine?
Yeah, why don't you screen share?
Okay,
Because that
first,
way, because you can't see what I'm looking at unless you screen share. But
okay,
there's in the first few seconds, there's something I want to ask you about. And my wife wanted to really know about it as well.
okay, let's see. Where is screen share? Is it down on
Oh,
more?
it's the big green arrow at the bottom of the screen. So if you drag your cursor down to the bottom of the screen, there should be a whole line of cursors or of icons that show up, and it's the big green one.
Okay, audio, video,
Keep going to the right.
participants, chat, react, oh, more. Yeah, it's probably in more.
Oh,
Share,
yours is different than mine. Yeah, my more is all the way at the end. The share is right after react.
share entire screen.
Yep.
Okay, share.
Boom. Got it.
All right, so we're going to watch Arabia Terra.
Yes, please.
Come on, come on. Let me try it this way. Where
I don't know
is,
why it's showing this. Click allow in the dialog box shown by your browser. You're already in the meeting.
yeah,
That's
okay.
weird.
Let's open this file. Okay, open recent Arabia Terra.
And that
Okay.
thumb drive that you sent me has some more of these on there. Your YouTube channel's only got two videos on there.
Oh yeah, that was 5 years ago or more. Okay, we're watching Arabia Terra, okay?
Yep.
All right, let me go to full screen. Okay, we're in full screen. You're on Third Street. Okay. Ready? Here we
Yes.
go. Do you want the piano?
Yeah, you can put it on. The music's nice.
Yeah, I used GarageBand to write the music.
Yeah, I thought it was very nice. That's weird. I can't see it on 3D on your screen, but I can see it on mine. That's
Oh,
weird. It's the screen share is not sharing the 3D image. That's weird. Okay.
that is
Oh,
weird.
pause. Pause. That was it. Go back a few seconds.
Okay, what's wrong?
Oh, nothing's wrong. It's just the thing that I wanted to talk about is just past the screen. Just
Okay.
go back. Just go back like 10 seconds.
That weird
That
dust
one.
pattern
That one.
is
Yep.
strange.
Yep, that claw. What
And
is that?
notice everything is covered with a layer of fine dust.
No, yeah, go back to that claw and then pause it on there. Is that a raised feature or a depression?
It appears to go up the ridge.
Okay, pause it.
So it looks like it's a pattern of material on the surface.
Made by Sasquatch?
Yeah. It's,
Martian Sasquatch?
well, that ridge that it comes off, that ridge has been eaten away by the electric arcs. The ridge to the right, the darker material, it's been eaten away by the electric arcs, and that's probably the remains of a vortex. You notice the filamentation?
Yeah.
It's some kind of a vortex that probably uh, erupted towards space and then petered out once
Wow.
the concentration of filamentation uh, dispersed.
Yeah, I mean it's
It's hard to
clear.
say how. Well, obviously, the main event disintegrated all the rock, and left the scalloped edges along the ridge line
Yes. Yeah.
and blew it all over the planet and into space. That's where the material went. And this is probably just some darker material that's settled back. Although it could also be some kind of a transverse electric discharge,
That's what I was thinking.
coming from it. You notice it's at right angles to the scalloped
Exactly.
of the ridge line.
Exactly.
So that's also a possibility. And down below it, you can see there's a faint kind of darkening area too.
Move your mouse over it and show me where you're looking.
Right behind this control panel
Oh,
here. Do you see my mouse, my
yes, I
cursor?
do. Yeah, I see
So
it.
right here. So anyway, continue.
Yes.
I also wanted to show you the dunes.
I told my wife about it because that was the first thing that she noticed on the video. On the other video that we're not watching, the first one. And I told her what you told me, that they were solidified dunes.
Yes. And on Cerberus Palace, you can clearly see welded tuff.
Oh, that's cool. Oh, there we go. Now it's going 3D.
Yeah.
It wasn't doing that a minute ago. I don't know why.
Notice the 120-degree angle at the top of that peak.
Right there.
The piece of a hexagon, of
Yeah.
course.
Yeah.
And a lot of the terraces on these peaks appear to be melted. They have blobby edges.
Melted.
Yeah, I'll show you as soon as we get to it.
My son just walked in with his roommate. I want to show him the video. So pause for just a second. Oh, are those some of those dunes right there? Hey,
There's some
guys,
dune.
look. Steve,
Yeah,
hold on, pause
yeah,
just a
yeah,
second. Look at the
yeah,
screen.
yeah, yeah. Oh,
Here, let me hit play.
I have to hit
Here,
play.
there's another set of glasses right around here. Oh, they're on my head. Here, look at this.
I'll hit play. Ready?
Oh no, we're watching. Hold on a sec. We're watching. I'm just showing my boys on the big screen. Hold on just a sec, Steve. So this is Mars.
Oh, that's sick.
This is Mars. And
What
this,
are
and
you watching?
I'm on a live Zoom call right now with the guy who did it.
Oh, that's so cool. Awesome.
Are you watching the one we're watching,
Yeah,
Arabia
we're
Terra?
watching the same one.
Okay,
We're just about a minute ahead.
I see.
We're just passing the first big mountain with with regular red top. If you just look at it with
Why don't you let me play it so I can tell where you are? I can have a little explanation.
here. Okay, that's a great idea. Okay, Steve, we're at 137. Okay, he's gonna narrate this. It's only just a couple minutes long.
Yeah,
Oh,
yeah.
you're at
Can you shut the
137.
door real quick? It's getting hot outside. Here, you guys can sit down here.
Okay. We should do another one instead of this one then. This does not have as many of the oddball features as you want to see.
Well, let's go do the other one then.
Okay.
I'll pull it up. The first one, not okay. We're just gonna pause on this and I'm gonna change videos.
All right. Let's see. Open QuickTime Player.
Oh, you know what? I can probably just broadcast my laptop to the big screen. Let me see if I can do this.
Yeah, you should be able to. All
Should
TVs
be
are
able
smart
to.
TVs these days.
Yeah. Let's see if this is gonna.
We were talking about dunes, like how they don't move.
Yeah.
And Nili Patera is a perfect example of that.
Is it?
The only words that
Yes.
very light in the middle. Ah. Was it one of those like visual illusion things?
Tell me when you're ready and I'll start.
So you don't mind thoughts once you look at it. They're no longer there.
Okay, I'm gonna change this. Okay, we're not gonna look at the big screen. Just look at this one. It'll be the same.
Oh,
Just hold
you
that for a
can't-
second. I'm gonna
Oh.
get a kid. Steve, go ahead.
All right. How's the volume?
That's good. Or you can just set it down on the ottoman. Oh, okay.
Notice the dunes. The dunes are all made of hematite, which is iron oxide. And they're sitting on top of this material, that's silicon dioxide. Notice also how many of these dunes have vertical striations.
Yeah, they do.
See this one in the middle? It's got vertical striations, meaning the sand grains are aligned vertically and frozen in place. Otherwise, they would slump. Notice
Right.
also how
Right, because
the edges of these things are so sharply defined. And they have these moving features across their surfaces, like filamentation.
But the biggest point here is that these dunes are not like Earth dunes. These are frozen solid. They're not frozen, but they're solid. They're solidified.
Solid. Thus,
Yeah.
when you look at the leading edge of what look like barpan dunes, they're shiny.
They're shiny.
Notice how they're
Right there.
shiny.
There's one. Yeah, right there, right there.
It's nostril shape here. Notice how its leading edge is it looks like it's what's the word I'm looking for? Vitrified, glassified.
Well, what these look like,
Look at this vertical alignment here.
this is very much like Fantasy Canyon, except without the Lichtenberg patterns. They're just
And
frozen in
notice how
place.
the crater has the material pulled away from the rim.
They
These are
what?
all created by ionic winds. Notice the big mound on the left. All of
Yeah.
this goes downstream or downwind.
I'm having a hard time hearing you. Can you talk? Bring your microphone closer.
How about if I turn the music down a bit? Is that better?
Yeah, that's definitely better.
I have to sit closer.
That'll work.
Look at this point here on the left.
Yeah.
You see what I mean by the shininess here on the top left?
Yes.
And then at the very base of it, you have this darkened ultrafine dust.
I'm guessing like right down in there.
Yeah, these winds don't, or dunes don't move. They don't blow around.
Right.
In fact, these are the ones where Alan Tremaine from the Mars group says that it would take 1,000 years for a dune to move 1 meter.
Why would it move at all if it's frozen in place? If it's solidified.
Because of the fine dust that accumulates on the surface. You know, it gradually flows down. He's not saying these move because these apparently do not move.
Right.
You'll notice that the area around them is swept clean.
Yeah.
There's no sand in which these dunes are deposited. Let me give you another one here, which I find very interesting.
Crazy. So anyway, this is from
Terra.
the.
Oh
Isn't
yeah,
this
we've
the
seen-
Mars? The
What?
Mars orbiter?
What about Mars orbiter?
That's where these images came from.
Yes, they came from the Mars Reconnaissance Orbiter, the high-rise camera.
Right.
There's a website called HIRISE.com.
Yep.
Let me see. First off, crater. Here's a good one.
Anyway, I'm recording this, so if you guys need to go, if you want to watch it later, you're welcome to.
Well, you have them all on your thumb drive.
I do. I do. I'm just upstairs. I'm not down in the lab, so
Gotcha.
I brought my laptop up and I didn't want to fool with trying to make it open. I didn't want to have to trick it to open the thumb drive. I just wanted to go to YouTube and pull it open easily.
Okay, here, this one shows electric geology a lot better.
In what way?
You'll see it looks like the surface has been clawed, like here, right in the sand. See that mountain that's been clawed away and the dark material is spilling down the side?
Well, just pause it and put your cursor on it.
Like right here. See all these terraces, like right here on the far right? See how the mountain looks like it's been clawed away and all the dust and sand has spilled down in a gigantic wash
Yes,
on the far right, right here. Can you see my cursor?
in 3D. Yeah.
And how the terraces are not,
We just woke
these
up.
are similar. This just looks just like a structure in Monument Valley where the sandstone have these 30 to 45 degree slopes.
Yep.
And they're only lightly dusted with material. They're not talus slopes. They're terraces of molten rock that are then covered with sand. Like the one in the middle. Notice
Yeah.
all those terraces are all covered with sand. And all the ripples. See all the ripples?
Oh, yeah.
This is why I say the ripple structures in the channeled scablands are not water. Because what we need to do is interpret features on Earth according to what we see on other planets, as opposed to interpreting other planets as what we see on Earth. Consequently, planetary scientists tend to think that, well, Mars must have once had water because these features are available on Earth, and obviously they were created by water. No sane geologist will say that these features are electrical in nature. So we'll continue here.
Yeah. Why that's
See those terraces on the far left? See
Yeah.
how they're solidified and covered with dust.
Yeah.
And that dust is magnesium or iron oxide. And all the white area you see is silicon dioxide. That's quartz. So this is evidence for transmutation of elements. You see where the electricity demolished the silicon dioxide mountain and converted it through transmutation into iron oxide, because two particles of silicon will make one particle of iron. So two atomic silicon and iron are half the atomic number of each other. So iron is twice the atomic number of silicon, meaning
Well,
it has twice the number of protons.
that would tend to lead me to believe that we're obviously seeing layers. I wonder, is this double layered?
No, they're not layers, they're terraces.
Yeah.
This was once a solid mountain, and the electricity carved the terraces. The terraces were not under the ground and then revealed. They were made.
Okay, thanks.
They were actually made by the electric currents.
Right.
You see what I'm saying?
Yeah, I do.
Because you see all the holes that are dug. There's these giant holes everywhere too, along with the terraces. And notice the straight line, quote unquote, fault line. See, follow my
All
cursor.
right, see you guys.
See that quote unquote fault line?
Yeah, right there.
That makes everything offset. See, everything's offset by a certain number of degrees. Like see right here.
Right there.
See,
Yeah.
see how that area is offset from its original location?
It looks like it. It does look
Yeah.
like that, yes.
So we were talking one day and we agreed that electricity is kind of a pulling force. It reaches in to conductive materials and pulls on it and rips it apart, or it turns it into dust, yanks it up into the air, and then crushes it in a Z-pinch to a solid material. Like here, all these areas here that are converted to dust. So let's continue a little bit. This has a lot of different stuff on it.
Well, those big long lines on the right
Yes.
that just kind of bifurcate the two patterns above and below it are pretty interesting as
Well,
well.
you notice all the swirls, that go up
Yeah.
and around and
Yeah.
over, and look at that giant mound right there, and the one on the right side that are all converted into these terraces. The one on the right has a point on top.
Yep.
And look at all those ripples.
Look at the ripples.
Yes,
That's
the
one thing
ripples in the
I
material.
haven't seen in my lab are ripples like this.
Use magnetic material. Use magnetite and hematite.
All right. I'll do that.
And then the electricity will have something to grab hold of.
All right.
Notice these structures here where it looks like the claws have dug into the top of this cliff
Yep.
and then dug the material out and spread it down the terraces into these big giant fans. Remember that you would be smaller than a pixel in this image.
Goodness sakes.
So you have to realize what it would be like trying to get around on Mars. Impossible.
Very, very, very difficult.
You'd have to climb these gigantic slopes of loose material and these huge terraces that are probably 150, 200 meters high.
So how can you tell which of the material is solidified and which isn't?
Because over the years it hasn't moved.
Oh, okay. So just pictures over the years. Okay, that makes
Yes.
sense.
Because the first images I had of Mars were way back, back in like 2009. So that's where I started working with there's Mars Odyssey is also still in orbit, and that's a project ESA put up there many, many years ago.
Oh,
So
that's cool.
there's still 3D imagers orbiting Mars in polar orbits. That's how we get these 3D images. The orbiter goes past this place on the left and takes a blue channel. Then it goes past the place on the right and then takes a red channel. So it's like you're at 60,000 feet with 100-mile wide eyes.
That's really cool.
Yeah, so here we go. And look at these swirls. They're embossed in the surface. They're cut and etched into the surface. And the interesting thing is the transverse electric discharges, which are all the ripples in between them. See, here's those claws in the top of this mountain again.
Yep.
All the dark hematite spilling down. Doesn't that remind you of like the area around Factory Butte? Like, look at all that scorched material at the base of that butte.
Those ripples coming off that last butte that's just exiting the screen now really just look like that was the center point of one of the discharges, and the fringe effect is just splaying it out. I've seen that in
Yeah, corona discharges
corona discharges.
are
Yep.
what they call transverse electric discharges.
Because when I use steel powder and I put
Yes,
an electrode
see
like,
that?
yeah, Yeah,
Isn't
there.
that incredible?
It looks
Even
just
this one,
like that,
look at that.
except it's frozen in space in place.
Yeah, this is all frozen in place. See how the edges of these terraces are all chipped away like something nibbled at them?
I can duplicate this in my lab, Steve, and I have. I've seen
Those are
it.
those are hexagons. Those are the edges of hexagons.
Go back. Let me see that again.
That all these, see this ridge right here? If you zoom in on these types of ridges, they're sawtooth.
Oh, are they really?
Yes. I'll show you that in another video. Well, you saw the video of Schiaparelli Crater, right?
Yes, I did.
With all the terraces
Yep.
and the hexagons.
I don't remember the hexagons, but I have seen them before. Yes.
Well, the center of Schiaparelli Crater is not a crater, it's a mound. And hexagonal patterns are etched into the mound in a spiral shape, rising to the center.
That's pretty cool.
So is your son still watching?
No, they had to leave. He's in the middle of moving his roommate.
Notice how this all looks like the Southwest.
It totally does.
And all this ultrafine scorched dust,
I'm
black.
Yeah, I'm getting the feeling that we're seeing multiple strike events. Like this isn't just one.
Oh, yeah.
Like when
Planetary,
right,
moving over time. Because you can tell that the ionic winds are going different directions.
that the ionic winds are going different directions. You see strata forming in different directions. You see patterning that looks like it's overlaid on top of other patterns. You're like, the same strike wouldn't have created these two patterns at that same spot. It might have
Right.
made one first and then another one at another time.
Right. Let's see. The best one to show a lot of this is
But that's the story that, Dave Talbot has put together is that Mars oscillated back and forth between Earth and Venus. And every time it got close, it would discharge.
here. This one shows that really well.
Oh, goodness.
This one really shows the. Oops, don't want that one.
Yeah, the fact that those are all frozen in place is just tremendous. Otherwise, you
This
think,
one
well,
really shows the Rosenzweig instability. Remember when I discussed that in my 3D Mars presentation?
I do. Yes.
There's those conical structures that are sliced in half.
Yeah.
They're all over this one. And look how these swirls and ripples are all etched into the solid rock.
It's leaving me speechless.
Here's some of the Rosenzweig instability, these mounds.
Again, it feels like I'm looking at multiple events layered on top of each other.
Yes.
It really does.
Well, there could also be different variations within the plasma cloud.
Or that, and that.
Like, look at this giant swirl with right in the middle that that huge mound with blackened edges.
Yep. Well, I was looking at the one just to the left of it.
Yeah, here's the Rosenzweig instability. See the arc? And on the right-hand side, the multiple terraces going up into finer and finer layers. And look, here's Factory Butte on the left-hand side there.
Yeah.
Perfect,
Yeah, right there.
Looks just like it.
It does.
Look at these big amphitheaters. Look at that giant amphitheater.
Right.
And here's more Rosenzweig instability.
Well, what is that center screen?
That's just more layers, swirly marks and layering. from variations in the plasma discharge.
Wow, look at the right side. Whoa,
Yeah.
pause. Go back.
All aligned.
Pause and go back. Go back like 5 seconds.
Okay.
Yeah, right there, bottom right screen. Oh, nope, don't play it. Pause. Go back.
Sometimes there. Is that what you're
Back.
looking for?
Whoop, too far. Let it play. Right there, right there, right there. Right where right where you're, whoop.
Okay.
Nope.
Farther.
No, go back. You were there. Let it play. Keep going. I'll tell you when to pause.
Look at this giant cliff.
Yeah,
In fact, these are all giant cliffs.
right.
Remember, you're smaller than a pixel. Is this what you wanted?
No, keep going. Just leave your cursor there, but just okay, here it's coming up right here. 3, 2, 1, pause. Right there. Right where your cursor is. So you've got the striations coming down at a diagonal, and then crossways, you've got those frozen dunes.
Yes. You mean like
That's
here on the left?
yes. Oh no,
Yes.
no, on the right where your cursor. Oh, I'm sorry, that's my cursor. I'm sorry, I'm an idiot. This is my cursor.
Okay,
Right there. That.
I'm moving my cursor
Yeah, that.
right here.
So
These
you've got these,
crisscross.
but then you've got the ones at a 90-degree angle crossing over the top of them.
Oh yeah, the deposit of duning material over the top.
Right
Yeah.
over the top. That's, I mean, if that's not a perfect example of two different events, I don't know what
Yes.
is.
Well, it's the ionic winds. One event may have cut the material loose from the surface, and the other deposited the material behind. Yes. One was making these long furrows, and then another one was etching these crisscross, what I used to call railroad tracks.
Oh, sure.
Okay, let's
I think they look
continue.
like bacon, but railroad tracks
Yeah,
works.
they look like bacon. But all the Rosenzweig, I was amazed when I first saw this. I came across the Rosenzweig instability completely by happen chance.
Oh, did you really? Tell
Yeah,
me, remind me again what the Rosenzweigen looks like.
it's
Just tell me.
ferromagnetic material. You'll either get these pointy things on these ferric liquids. You know how they make ferrous material, these
Yes,
liquids, and you expose them to magnetic fields, and they make these
the
pointy
points.
things sticking out. That's what these sticking out things are.
Oh, and that's like everything we're seeing on the screen right now.
Yes. And notice how they meet at 120-degree angles at the top, which is where the hexagon structures all come from. Because when you put these all together, they make a hexagon. And so, you can see these ridges are sticking out of the dust. They're buried.
Right.
So Mars is covered with a layer of fine dust.
Right, which is why when we,
Look
wow.
at how they
Wow.
meet in these perfect patterns, these pinch points.
Pause. Those dark craters, they're looking suspiciously hexagonal.
Yes, they
Lower left center.
yes, they probably have edges. Yeah, I can see what you
I can
mean.
see straight edges on some of those.
Yes, yes.
All right, go ahead.
Just like these mounds, the terraces don't go up and down them, they're cut into them. They don't like go up and down in a sine wave. They're
They're cut. Right.
They're cut.
Exactly.
Yeah.
Just like what Tafoni is on Earth.
There you go.
It's carved out. Oh wow, look at the bottom of that crater.
Yeah, that crater's got scan lines through it. You know, everything going.
Yeah, exactly. Exactly. Dude, this must have been a horrible, horrible day for Mars.
Man. It may have been over hundreds of years
I-
that
right.
these
I,
things
I,
took place,
I,
or
I know.
thousands.
I still think there's a possibility that we had civilizations and people on Mars that were just absolutely obliterated by this.
Really,
I know that's not where you're going, but I wouldn't be surprised if we actually find remnants.
of an old civilization.
Yes.
Hmm.
Because if Mars was in the envelope that Saturn was in, that should have been very conducive to life.
Hmm. Well, I really can't comment on that.
Yeah, I know.
There's
It's a wild
nothing I can
speculation.
say.
It's wild speculation on my part, and I freely admit it. So if I'm
Well,
wrong,
everything is wild speculation that we're discussing.
well, here, let's take it into the fun realm. If that's the case, and there was that, then there should be a lot of ghosts on Mars too.
Yeah, electromagnetic phantoms.
Yeah,
Who knows what the Martian metabolism may have been? Maybe it was conducive to preservation.
I know. I know.
You
That'd
know,
be
there's,
cool.
yeah.
All right, what are
And
you showing me next?
I'm trying to find, oh, Cerberus Palace. That's the one I really wanted to look at.
Cool.
There we go. It's the one that has all the, it's got all the transverse electric discharges.
Cool.
The first one I made.
The scalloping on that edge of that's on the left-hand side.
Look at all the mounds on top too,
Yeah,
and all the little craters slammed into it. Look at the edges have all been eaten away.
that's what I'm talking about.
These giant channels in between.
It would be fun to it would be fun
Keep in mind how huge these structures are.
yeah, it's mind-blowing.
Did you ask me to pause it?
Oh, I'm glad no, but I'm glad you did because that shot right there. Hold on, let me see if I can screenshot that. Hold on just a second. How do I screenshot? Where's my screenshot? There it is. Hold on.
This is why people think there was water, because they interpret these ripples as water. But they can't explain how the ripple has ripples coming off it at 90-degree angles.
Right.
You know, the ripples are there, but then they have ripples, and then they have ripples, little tiny tendrils at the ends, and how they're bifurcated,
Yeah.
like the one at the very bottom. See how it's bifurcated?
Move your mouse and show me.
The ripple here at the very bottom,
Oh, yeah, yeah, yeah. I see it. I see it.
that bifurcation.
Right.
And how this loose material is stuck to the sides of these cliffs.
Yeah.
It's just
Well,
welded tough.
yeah. Well, and the other thing is that crater that's on the side of the wall, right
Right,
in the center of the screen.
right. Yep.
That's awesome.
And this mound on the far right, shiny because it's hardened,
Yeah.
cut right in half.
Yeah. Cut right in half.
There's
That is a fantastic shot. Such a
some good
beautiful
ones
shot.
on this one, like
Wow.
this one here.
I'm
Look,
sorry.
there's the welded tough I was talking about. See,
Right.
it's stuck to the wall there on the
Yeah.
right.
Yeah. Center right. Yep.
Yeah.
Absolutely.
And look at this. Here's another one of those on the left, those giant mounds of sand. that's been cut off the cliff face, destroyed and deposited. Yeah. This was
Wow.
very hot at one point. This whole area was very hot.
Those two pinnacles down lower left center,
Oh
right
yeah.
near just wow, stunning.
You can just imagine they're just wham, wham.
Yeah.
And these whole big areas were just like, you know, and look at this giant pile of dust on the
Yep.
right. You know, how I was talking about Mount Thor and these other structures that have
Yeah.
a 30-degree slope and then a 90-degree edge. There you go.
There it is right there.
There it is.
Right there. The right side is in shadow, and that's the steep side, and the left side is very
Vertical.
wow. That one on the far right.
Yes.
It's like Evil
Look at
Knievel's
how all
ramp,
these cliffs. Well, here's that one right there in the middle. You've got the 45-degree
right?
slope and the
Exactly.
right angle at the side.
Yep.
The scalloped edges on this one at the top right.
Top right. It'd be fun
And
to zoom in on those little craters and see if they're circular or if they're hexagonal.
it's hard to say. The resolution is only about 720, maybe 480.
Look, pause. Pause. Center left. Look at the
Yeah,
channel on top of that mesa.
right.
That's cut. That is awesome.
Yep.
You got a
And
channel, you got a mound, you got craters on top.
that very smooth mound, it looks like an egg under the
It
surface.
it totally looks like an egg. All right,
Very
go ahead.
smooth.
But just those little rivulets and channels right on top of that mesa.
Well, the one on the left, you see how it connects to one of the scalloped edges.
Yes,
So that was a lightning bolt of some kind traveling across that feature,
exactly. Traveling right across it.
right across it, cutting deeply and cutting more shallowly. And
Yep. Just, oh my goodness, look at that huge channel on the right.
yeah, a transverse electric discharge channel.
Right, exactly. And see, what's so cool about that is it's so clean. The edges of it are so clean.
And look how that edge cuts that crater like into
Exactly.
three-thirds.
And you're thinking if that was water, that crater would have just been huge or washed away or whatnot. And it's not, it's just clean.
And why is that crater on the bottom left? Why did the edge go around it?
Right.
You know?
I know.
And it's a twin crater. The wall is the edge of the
Yeah.
ridge, the wall of that crater. Yeah, this
Wow.
one has a lot of structure in it.
So cool. Which video is this called?
Cerberus Palace.
Cerberus. Yeah, that you were right, Steve. This is fantastic.
This one and Fursoff crater and Becquerel crater.
Uh,
We'll have to look at Becquerel.
we're looking at well, there's Monument Valley again.
Yeah, there's at the top right there.
Temple Rock.
There's a 45-degree angle with a vertical cliff. And look at these giant mounds of sand.
Whoa.
They bury everything.
Wow.
So it looks like the channels were cut and then the giant mounds were eroded away
I think that's exactly what it was.
and spilled down.
Yes.
Look at that.
That's just wow. That makes
You
our
know,
Monument Valley look like kindergarten stuff.
yeah, and this looks like Mount Kilimanjaro.
Which one? The upper right or upper
This one
left
on
or
the left.
yeah.
Look at this arc shape on the right-hand side with the welded tuff on the face.
Wow.
See the one on the right here?
Yes. Yeah, I can see where your cursor
You
is.
can see how sharp it is too. See its shadow?
It's like a knife blade.
Yeah, it's a knife blade. Amazing. This
Oh,
all reminds me of the channeled scablands.
oh, that's why it looks
In fact,
familiar.
there's a structure in the channeled scablands called the blade.
I remember studying that, looking over that very detailed. Oh my
Look at
goodness.
that crater. Wow.
Yeah. But look,
Amazing.
it almost looks like, I mean, the story that I tell myself in my head is this big patch up here in the upper left, this big mesa is kind of almost at the edge of one of the discharges, just because it's not it's influenced by it, but it's pretty tame compared to all the sharply cut stuff we've just finished seeing.
Yeah, and yet that giant mesa has a shallow depression on the top, you know,
With little rivulets all over the top of it.
all over the top of it.
And then that one sharp smashed edge with the crater, lower right. Oh my goodness, look at his neighbor.
Oh yeah. A lot
Goodness
of them have
sakes.
that fan shape. You know how they start from a point and go out into a fan shape?
Yeah,
That one we just flew over.
I'm looking
Yeah,
for
this is like in a supersonic jet at about 60,000 feet.
that's
That's about how I interpret it.
well, and the other thing, and you said this earlier, and I'm going to have to agree, it looks like, you have different type of discharges and different effects, which show that the actual discharge or discharges itself were not homogeneous. Were broken up into little pieces and parts. Some parts were stronger than others. Some parts were moving different relative to other ones, and it just caused all sorts of effects.
We really don't know. I mean, you do your experiments in the lab, but we really have no idea what electricity on this scale does
Agreed. I
or
mean,
how it acts.
I mean, aside from what we're looking at, and again, we don't know if this is one event, five events, 100 events. We don't know the amperage, the voltage, nothing. Agreed.
It looks like they were piled on top of each other within a fairly recent or a fairly short time frame.
I can see two clearly distinctive layers. I can.
Yes. Well, like the ripples here, you can tell that they're, I used the word entrained the last time, they don't move because the giant sand pile flows down and buries them. It doesn't move them away, it buries them
Yeah,
like they're solid.
right.
See how all the dust just covers up those ripples. And you see how over on the left,
Yes.
see how the ripples translate into the furrows. The ripples in the side of the cliff here on this left-hand
No, I
side,
see that, and they go right up.
and they go right up, they go from a ripple to a furrow. Is that polarity?
I think that's exactly what that is. I think that's absolutely polarity. I would love to go down there, and I realize this would be quite a hell of a hike, but walk on the dark part with the part and just take a magnetometer or any type of measuring device. You would see a polarity difference.
Yes. Well, there's
Because
severe magnetic differences on the surface of Mars. Extreme.
that's actually a really good point right there to see that, because those that's weird. The channels go from a valley to a crest to a mountain.
Yes.
That is crazy.
With in one breath.
In one breath.
There's no, I mean, the transition is almost impossible to see. It would be interesting. I could have gone closer in some of these, but then you would have had to crush your eyes. But
That one right there would be
these
worth.
features, it's turtles all the way down. These features just keep going smaller and smaller and smaller.
But just think,
Let's look at Becquerel crater real quick.
yes. Well, that by far, Steve, is my favorite 3D video. That was mind-blowing.
Yes, that one has this one is a little harder to see because it's closer. Can you see it?
Well, I'm looking. I can see that. Yes, I can see the image.
You can see the pit. See the pits, these terraces.
It's not resolving into 3D. I right
You
center
have to get
screen, I can tell that's a point that's sticking up.
your eyes have to get used to this one.
Yeah, it's
You kind of have to cross them a little more. I'll try to leave. See if you can resolve this image.
it's not resolving. It's
In the bottom middle, there is a nipple. That would be a nipple.
okay, yeah,
See
I
if
could
your
see
eyes
that.
can. Okay.
Bottom right side.
Yes. So
Yeah,
you can see now from that nipple, you see that these are all layers, terraces.
yes.
Okay. You notice how the edges of them all are all chipped away?
I don't know if
They're
I can
all
see
eaten
that.
away. When I first saw this image, here, I'll just keep playing. When I first saw these images, I thought those dark bands were layers of dust. But in reality, the dark bands are the scorched edges where the fulgurites ate away at these cliffs, these terraces. Those are actually holes.
What are
They're
holes?
cuts into the edge.
What are
Can you get
holes?
it yet? This is a hard one.
Sorry, say that again.
This is a hard one to see.
Well, there's all sorts of stuff going on in here.
Yeah.
Those little fault lines on the left-hand side that we just went past.
Yes, that long straight line
The
that
long straight line
cuts through everything
cuts through everything and offset it just a little bit.
and offset it. Yes. Look at these ridge lines here on the right.
What in the world? See, okay, pause. Like, pause. So the center, that fold that's right in the center of the screen,
Oh, where that kink happens?
yeah, that
Yeah.
kink, that little bump,
It goes up to the top
it
of the
goes
road.
up, exactly. But I mean, what that tells me is that these discharge effects, I mean, we're looking at them essentially planier, essentially, but they're actually, going up and down as well and deep into the surface and doing weird stuff as well.
And leaving behind these hogbacks, these knife-edged hogbacks.
Yes, thank you for finishing my sentence and leaving
Oh,
them behind. What's this? Oh, that is a nipple on the upper right quadrant.
yes. Lots of nipples in this.
But that's interesting because on the rest of this scene that right now, that's like the only one that's present. Oh, did you just back up or go forward?
I'm trying to get it to start again. It's glitching. QuickTime has a problem. Let me start it again.
Okay, there it is. Yeah, that's where we were. But see, look, even at the top, whoops, the
I'm
top
trying to,
right, there was what looked like a valley that bifurcated the the strata, and the strata just followed that bifurcation. Oh, we're way back at the beginning now, aren't we?
yeah, yeah. So you can see the nipple in the middle. It's
Yep.
square. And then on
Yeah.
the left, you have a triangular one.
Yep.
Okay, let's see if I can get it to play from back here.
Yeah, it's geeking out a little bit.
There's that straight line that's
There,
offsetting
yep.
everything.
That's offset everything.
That is weird, isn't it?
It really is.
That is so strange.
I'm gonna show that I'm gonna take a screenshot of that, send it over to Andy Hall because he has talked about that before. I'm gonna see what he says about that.
Those weird features on Mars. Let me start this one again. Okay, Becquerel crater. All right.
This one isn't resolving so well in 3D.
It's the same one as we just played.
I know, and it didn't resolve the first time I looked at it too.
It's hard because it's smaller. You have to cross your eyes more. The middle of the eye zoomed way in on this one. This is about as close as I can go.
Okay, so there's the nipple, there's the triangular one.
Okay, so you get the 3D effect there. And
Yeah,
there's
the triangle
there's-
one is definitely sitting above the surface. I can see that. Not
There's the
above the
ridge.
surface, but it's
You
raised
see
above.
right beside the ridge that other area is a depression.
Where?
Look at even the curve in
Yeah.
that ridge is offset in that fault.
See,
Even the
and that's
curve.
right. And that curve, the offsetting curve is not going to be wind and water. That can't be wind and water. That just is nonsensical.
Impossible.
I'll go with impossible. Yeah.
Are you uncovering a structure that was previously buried that's offset? Or is whatever created the structure the thing that offset it?
That is a great question. I tend to lead toward the second, the latter, that the thing that created it is the thing that's offsetting it.
Me too. Polarity effects create the
I
striation.
I agree.
The 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 electric discharge is reversing polarity in its filamentation.
Yeah. And then all of a sudden everything just that. It's like everybody
It's
to the
all
right.
being thrown up into the air, you know?
Well, and I've done enough experiments that I can see that when I apply an electric field, it stratifies the materials that I'm working with.
Imagine the noise.
It what?
Imagine the noise from these effects.
Sorry, I didn't hear that.
Noise. I'm trying to turn my screen down.
Oh, thank you. Yes.
I said, imagine the noise.
Oh, imagine the noise. I
Yes.
don't want to. I can imagine it would be have been horrible.
Your mind probably wouldn't have been able to take it. I used to say, boy, I'd love to see what this was like when it was happening, but it would probably just wreck your mind. You wouldn't be able to take it. You wouldn't be able to accept what was
I
happening.
agree. I mean, because there was even smells involved. Because
Oh,
when
of
I do this
course.
in the lab, it creates ozone, it creates, the burning of the material sometimes. So you got sight, sound, and smells that you're gonna have to
Yes.
deal with.
Yes. Imagine all the sulfur dioxide,
Oh, there would be horrible, horrible smells.
hydrogen dioxide,
Yeah.
stuff that would burn your lungs out,
So many ways to die if you were witness to this.
hydrogen chloride gas,
No, thank you.
covering the whole planet.
See, this
Incandescent heat.
this almost looks melted right in through here.
Oh yeah, yeah, yeah.
But
It is
melted.
melt. Look at the you know how the edges instead of being scalloped, they're almost globular.
Yep.
Like they were pinched like little pinched droplets.
And yet they were still the minerals were still segregated. So you're like, what can segregate minerals and make it liquid and flowy?
Yeah,
Wind and water?
right.
Nope.
Yes. Well, the magnetite and the hematite acted like fluid because they were ultrafine dust, completely pulverized, and the electromagnetic fields just pulled them here and there,
Whoa.
like
This
rivers of dust that then solidified because they were
right.
like what happens when a lahar comes off of a volcano, the pumice, what do they call that? A pyroclastic flow.
Pyroclastic flow.
Once the dust stops, it freezes in place immediately. It becomes stone instantaneously.
That's
Same
pretty
thing
cool.
here. You see, it became stone instantly. And
That's amazing.
the hot dust
Hot dust just zip.
compressed in these filamentary Z pinches Imagine all the Z pinches going on, just kapow, kapow, kapow,
Well, I think,
making what look like potholes.
or those little pointed nipples, like what you said, the those I can't remember what you called those 10 minutes ago.
The buttes.
The buttes, but you gave them a specific name. The oh crap, what was it called? That the not an instability, but you called it something else.
Oh, the Rosenzweig
The
instability.
Rosenzweigen. Yep. But I'm
Rosens.
looking at this. I'm wondering if the Rosenzweigen aren't those examples of a Z pinch. So it Z pinches and goes zoop, zoop, zoop.
Well, that's what I'm saying. You see these oval structures everywhere cut into the surface. I think that's what's happening here is within the filamentary cloud of plasma, you're getting these Z pinches creating like potholes. They're super powered, like this one here in the top middle. They're super powered in that area, so they burn for a brief second. And then while everything else is swirling around, this superheated dust storm.
Well, and that's another thing too that you can't forget. And don't go past the screen yet because I wanted to point at something else. But you've got the ionization creating movement, and you have the supersonic winds from actual arc discharges. Both of those happening at the same time.
Yes.
I mean, it's just talk about an absolute catastrophe.
Plus
But
steam.
that
Steam from Earth.
three,
Steam Earth.
right? Exactly. So
I think there are water features on Mars, but they were transitory to this single event where where Earth and Mars, did their deal.
did their little dance. This screen that you've stopped on is not flat at all. It's resolving. It is extremely the terrain is very, very noticeable.
Yeah.
And when you
Like I
talk
was
about
saying earlier, imagine having to walk around in
that I don't know how you do this. I mean, this is crazy.
Yeah. You couldn't explore this.
Not without like tons of rappelling equipment.
Yeah. You'd be climbing a mountain like every 100 yards.
I know.
Like you have to keep in mind, you're not visible in this landscape. You're an ant.
Right.
You're a little ant.
Well, the bottom center looks like a ridge, and if you follow that ridge up, it goes down into a huge canyon.
Well, look at these canyons.
Yeah. Just
Look at this pointy. You see this point here,
yeah.
this multi-layered point in the middle.
Yeah.
And then over to the left is a square.
Yeah.
That square indicates an extremely powerful electric discharge because the fewer sides, the more powerful.
Oh, is that how it goes?
Hexagons and then squares, and then hexagons, pentagons, and squares.
Oh.
And then the triangles like these pointy arrowhead features.
Oh, cool. I didn't know that.
And you notice on the right here, this jaggedy looking terrain,
Yeah.
it is jaggedy. All of that is eaten away. Those are little holes punched into the surface that are creating these terraces.
Right.
The terrace right here beside the square, in between the arrowhead and the square, all those terraces in that amphitheater.
Yeah.
Can you resolve that?
Yes.
That amphitheater? Those like I said, I used to think that darkening was dust or layers of dirt or dust, but no, it's blackening. Those dark layers are blackening from fulgurites. These are all the edges of fulgurites, just like the Southwest, just like the desert varnish. This is desert varnish on all the sides of all these features is desert varnish.
See,
like
so
some of them here. Let me show you.
I think if none of this is moving, like you say, I think all of this is essentially fulgurites, everything that we're looking at here.
Yeah,
'Cause-
like here's that here on the left here, you see? Here's that that what you call it, polarity. Because here, instead of the things being cut into the surface, they're embossed. See all the fault lines that are embossed
we
instead of being cut?
so on Earth we call them ories.
Ories or dikes,
Yep.
hardened dikes
That
within the
actually
material.
sit above the surface that you're on. Little
Yes.
veins, little 3D veins. Yep.
They go right to the edges of the cliffs up those 45-degree slopes and then zip, they go right to the edge and they march across the landscape, one right after the other.
Yeah, and to say that was carved out by a wind of water is just it's nonsensical. Oh crap.
They think it's wind. See the centipede on the far right?
Mm,
Can you see the giant centipede?
put your cursor on it.
Let's see if I can right here. Can you see
Oh
my
yeah. I got it.
see him? He extends off into the bit where you can't see 3D. But yeah, he looks like a gigantic centipede sitting on top of the mountain.
Yeah, he does. But
And
that's
this
another
little go
that's another example of those vertical dunes frozen in place.
right. Only in this case, it's solid rock.
Wow.
Yeah, these aren't dunes at all. These are very little of this is covered with sand.
Oh, this is all
Most
just
of this is
wow.
solid stone. Like see
Yeah.
this area, for example.
Okay,
You
yeah,
can
yeah.
see some, like here on the right, you can see some darkened sand. But then these hogbacks are vertical stone ridges.
Wow.
Yeah, this is the thing about Mars that we didn't get a chance to talk about on my last presentation. I just started listening to Andy Hall and Gerald,
Jeffrey Drum.
Jeffrey.
Good.
It's hard for me to listen to other people.
It's
I'm
hard for
so
me to
self-centered.
actually watch myself because I have to
Yeah,
review these and I hate watching myself.
yeah. You go, why did I say that?
Yeah, just my timing goes off, or I just sit there like a dummy looking at the screen and you're saying something and I don't. What is that?
Look at all that
Pause.
darkening.
Pause.
That's a giant chasm.
No. Before the, yeah, the giant chasm, but I'm looking at the glowing left-hand side of the screen.
Oh, yeah, that's
Oh,
that
whoa,
light
too far.
area. Yeah,
I mean, it's
you're
just the
probably
red.
looking at silicon dioxide as opposed to hematite.
Okay.
Like the bright ridges here would be the underlying silicon dioxide. And then the darkened areas like the road, like the terraces, these are all hematite and uh, burned edges. But yeah, these are all fulgurites. Everything is fulgurites.
Right. Well, and
Like,
see,
look at this.
good.
Just incredible.
It is. I mean, that looks like someone has done like marbling with paint.
Yeah, except that they're 3D, they're deep. Those dark, see, that one, especially on the left there, that's lobate, it has a flat silicon floor and then burned edges, cliffs of burned edges, and then another terrace of flat silicon, and then more burned edges and
Gee,
they climb up to the top of that nipple. That
climate. That's what I want. That was exactly what I was thinking of, is what would it be like to climb up that and look down? Because
you're
there's places in southern Utah that look very, very similar to this. Have you seen those
oh
places?
yeah,
Out
yeah,
near out in Zions.
yeah. These what they call hidden canyons that hardly anyone has been to because they're so difficult to get there. There's no roads or anything.
They are, but they have these wavy, marbled look to them. And they've
Well,
been photographed. They're very popular.
Monument Valley itself is a big arc.
Oh, is it?
Yeah. All those, those structures that
The
look like
pinnacles? Yeah.
with the fingers coming off them.
Yeah.
Some of them have index fingers and some of them have pinkies.
Yeah.
Some of them have a thumb. How?
Wind
And you
and
have to
water.
remember all the material around them is gone.
I know.
I used to think they were at the bottom of an ocean, and that the larger, like the Book Cliffs and the Schaefer structures, they were like the ocean edges. But now I realize no, there was no ocean there. There was rock, and then there wasn't rock. It all went into space.
So
And
I
also the mountains. You see these mountains like in Wyoming and Montana and such, and they say they're mountains made of fossils. And what they are is they're the material that was on the plains that was pushed aside by the electromagnetic forces and piled up
and piled up.
into
Yep.
molten mounds of bones and trees and rock and melted rock and mud and God.
Yeah.
And then just like put in an electric furnace
Yeah.
and just converted to stone like that,
Yep.
This
So one of the exactly, because I can go hiking up in the mountains just right outside my door and you find seashells at the tops of the mountains. You're like, hold on. Hold on. You're telling me that the mountain can erode, that the cliffs can erode over eons, but these little shells will stay there and not be eroded?
yeah, the top didn't erode.
I was like, come on. Come on.
I mean, the top eroded enough to reveal the seashells, but then stopped eroding. But the sides are all gone. It's like,
I
where?
know.
Why Chief Mountain? We remember long ago we looked at Chief Mountain on Google Maps. It's upside down, and that mountain in Montana, that's that big cube,
Yeah.
the
Yes.
big giant cube
Yeah.
that's like from 500 miles away. The whole piece is 500 miles away from its bedrock where it grew up.
Steve,
500 miles.
right. Stephen Amala from Finland, he used a word, and I can't remember what the word is, but it's a really big word, and we should put it in our lexicon. But it means exactly what you just said. It means that you find a thing very far distant from where it originated. And I can't remember what that word is. It's it's ana something. It's not anaphylactic, but it's something very much like that. I'll have to look it up. I wrote it down, but it means exactly that. That you're like, wait a minute, what's going on? Because apparently in Finland, there are a lot of rock features that are exactly that. They're transplanted.
Oh yeah,
They didn't originate where they were found.
right.
And
And
it's
no one knows really why. They attribute it to volcanism. What do they attribute this to on Mars?
volcanism.
They don't attribute it.
No. Magic. Harry Potter.
Yeah,
So
it's hard. It's hard to get a lot of this stuff across to people because what we're looking at is like the very tip top of the mountain that you have to climb to get to these ideas. You first, what is electricity, and what is plasma, and what are protons and electrons, and what is charge, and why is that important? And is there electricity in space? I mean, you have to go up these ladders. They're everywhere. The ladders are in every aspect of our science
they are.
and philosophy.
But what's nice is that the bottom of these ladders that you're describing really are two things, charge and geometry.
Mm.
Like for me personally, when I say, how is the universe created? What are the foundational attributes of it? It's charge and geometry. That's it. whatever charge is, whatever mystical thing that is charge, I don't know. And then the way charge forms itself with itself is what creates everything. That's what it looks like to me. So, oh well. Oh,
What is,
I was gonna tell you one other thing. We've talked a lot about Monument Valley. I actually recreated Monument Valley in my lab. Did I ever tell you that?
mm-mm.
So I took some dirt. I don't even know. It was sand. It was very fine grained sand. I put it in a plastic dish and I put an electrode underneath that dish. Right. So you have the wooden table, electrode, which was just a flat metal plate. Then you had a plastic dish. Then you had the sand. And then I took another electrode, which was just another flat plate about the size of my palm. I put that on top of it, turned on the power from the transformer for like 3 seconds, Steve. That's all it took. Lifted it off, and all of the material had excavated except for like 5 or 6 little mesas. It was
Interesting.
Monument Valley in a dish right there.
Interesting.
3 seconds. That's all it took. If I did
So
it
the material that remained was not as magnetically attractive, or
something. I don't know why. I don't know why some of those mesas remained, but it
oh,
just excavated the hell out of everything else and just left these little mesas right there.
fascinating.
It was pretty cool. And it wasn't even wet. This was dry
Well,
material, Steve.
well, there's Mars too.
Right? Right. So when you
Yeah,
say
I'm
the mesas
yeah,
do
I'm
this and
convinced all the
this,
mountain ranges are just the remnants, the debris from the Great Plains.
right?
The Colorado Rockies and the Appalachians and the northern tier mountains and all that are just the material that's been piled up out of the Great Plains and pushed off to the sides,
I
like the Arctic and all that.
Right. I always wondered if a lot of the red rock from the desert Southwest isn't Martian.
Well, it's rust.
Iron
You know,
oxide.
yeah, it's magnetite and hematite, just like Mars. The desert Southwest is sandstone, magnetite, and hematite.
I'm just wondering how much sharing of material there was between the two planets.
Where did that 5,000 feet thick of Navajo sandstone come from?
Where did it come from?
Yeah, it was molten at one point, or it was heated into stone. It was sand that was turned to stone with heat.
Right, and it could have been your the transfiguration of elements, transmutation of elements too. But
Well, we have our lithosphere is what oxygen, silicon, and iron, right? Aren't those the three? And aluminum
you got I'm not sure. And aluminum. I know there's a lot of aluminum in there. Yes,
and silicon. Lots of silicon because of the sandstone. So much sandstone. That's all silicon dioxide.
sure.
And this is where a lot of the oxygen went, from Mars is into these materials because they're silicates, carbonates, and
Oh,
oxides.
oh, I see. I see where you're going
Like
with this.
Mars is covered with silicon dioxide, calcium carbonate, and sulfates,
You're kind
iron
of making,
sulfate.
you're kind of adding evidence to my belief that there might have been life on Mars, because if that's where the oxygen went, and that means there was oxygen there, there was probably some kind of life.
You're talking about microscopic type life, perhaps. No, I don't think so. It's too small and it doesn't have an intrinsic magnetic field. So any organisms are exposed to the sun's radiation.
Yes, but that's how Mars is now. What was it like when it was still in Saturn's envelope?
Well, what would have discharged its electromagnetic field? I don't think it had one to begin with. And that
That's a good
induction,
point. That's a
yeah,
valid point.
yeah.
That's
Well,
a very valid point.
you see the surface, how the red and blue, those are alternating polarities. It looks like a big claw
Yeah.
went across the surface of Mars. leaving these alternating polarities of striation, as the sine wave crossed the center line, the AC arc. Where you cross the center line, that's where you get the polarity shift,
Yeah.
like on your scope.
Yeah.
Wherever you're crossing the center line, that's where your polarity is shifting to the negative, and then you're shifting to the positive, and the oscillations of the electric field.
Right. Well, you're
Can
going to
there
make
be an
some.
electric field without oscillation?
Could there be?
Is it possible to have an electric field without an oscillation?
I think. I'm
Well,
going to say yes, because if the scale gets big enough, that oscillation might take so long that our lifetimes are not long enough to observe the change. So I'm
like
going to
the
say yes, but
like the
that
galactic
field would have to be
superwave,
huge.
like the galactic superwave.
The galactic superwave, but we even have a smaller version of it, and that is the polarity flip of the sun, which
We have
is
no
within our
evidence. Oh,
lifetime.
yeah. That happened just recently, back in November, I think.
I didn't follow it, probably.
We're in solar max now,
Oh,
so
okay.
yeah, we're
Cool.
going to have far more sunspots.
Right.
Fewer electrons are going to reach the Earth, or protons. So we're
Okay.
not going to have as many clouds. You remember Henrik Svensmark? Yeah,
Is this the cloud guy?
the cloud mystery. Yeah,
Yes.
where he showed that with a cloud chamber, how the clouds in the atmosphere are created by cosmic rays.
Cosmic Rays. Yep, I do indeed. That's a
So,
great DVD. In fact, it might even be in this laptop that I'm holding right now in the disk drive.
oh,
I keep it in my computer because
I
I watch it
it's
every
on
now and again.
YouTube.
That's a great video. That's a great DVD. You sent that
I
to me.
I bought 5 of them from his producer,
Oh, you
and
did.
I mentioned that somebody had leaked it to YouTube, and he goes, "Well, that's violation of copyright."
I
But
didn't. I've watched it from the DVD, so
yeah, he never did anything about it, though.
mm,
Yeah, I still have one of the DVDs too. The only thing I disagreed with was the long ago stuff. Like
yeah.
millions of years ago, the climate was this and the climate was that. And oh, give me a break. It's like, they talk about millions of years, like they talk about last Tuesday. Like they're so sure. Oh yeah, we know for sure, for instance, that for certain that for some reason, for some time in the beginning, there were hot lumps. You know, what?
Thanks, thanks, Daddy, for that bedtime story.
Well, that's Camus' lament, where he's talking about science trying to explain reality to him. And, he's waiting with bated breath for them to describe the true nature of reality. And then they resort to these phantasms about planetary systems, and he goes, then I realize you've resorted to poetry.
Yeah.
I'll never know. All we have is metaphor. We have no truth. We'll never, ever
That's
have truth.
and that's why I just really started going into my lab and it's like, okay, I don't know what I can believe anymore. I'm just going to go do it myself.
Yeah.
I've got a
Become a
transformer.
naturalist. Yeah.
I'm, I'm going to zap stuff and see what it does. And what's cool is when I zap stuff, it looks like the stuff that we just finished looking at. And you're like,
Yeah.
oh, I think we're starting to go down the actual path of truth, which is really fun.
Hey,
Really
whatever
cool.
happened to Billy Yelverton?
I don't know. I've reached out to him a few years ago, never heard back from him.
Hmm.
I
He
would
was an
love,
old guy.
is he? I don't know how old he is, but yeah, I would love to talk with him and redo some of his stuff. I still wish, what's his face was still alive. Um,
Steinbacher.
Steinbacher. But
Yeah.
yeah, I
He
would
was a
love
reach, he
Yelverton
was a
to.
reacher outer.
He what?
He was a reacher outer. He reached out to people.
Oh, that's
He
cool.
didn't he didn't mind talking to anybody about the electric universe. When he lived with Michael Armstrong up in Oregon, because he couldn't stand Michael Armstrong, who can, he would go out for walks all day. So he would walk around Beaverton and Portland all day and
Wow.
just talk to people about the electric universe that he would meet on the street.
Oh, that's fun.
When I lived in Fort Bragg, I was going to give all these seven 3D presentations to for people to come and see. You know, show them on a big 65-inch plasma screen and
Ooh,
give people free 3D glasses and charge them $5 to come and see it. Because everyone was bored in Fort Bragg. There was nothing to do there. It was really small little town full of Mexicans and retirees. That was basically it.
not much to do.
Nothing to do really, unless you like to lay on the beach or walk around in the mountains, which
Which
I did.
I think those are two really great things to do. That
Beautiful,
sounds
clean
awesome.
air, beautiful, just a beautiful, incredibly beautiful place.
Yeah,
I was
that's really
sorry to have to
nice.
leave it. But anyway,
Yep.
so anyway, there's let's see, we saw about what, three videos. I've got four more. Yeah, I really think those dunes are fascinating. You know, the Nili Patera, where the striations on the dunes are vertical.
Yes.
You know, normally, how do you get striations on dunes? It's the wind,
It's the
right?
wind.
The wind makes the ripples. Well, what's blowing straight up and then
And
traveling
then
side to side
right, and then freezing it in place.
and then freezing in place? Yeah.
And not wind.
And the ones that have those things that come out and then they have the point, and then surrounding the point will be this oval. And inside the oval, the edges are just so shiny because they're frozen in place.
Yeah.
Until they're fine, fine sand that's been melted in place. What do they call that? Vitrified.
Vitrified. And
Yes.
vitrification, I've learned just from my own experience that vitrification is specifically when it turns to glass or glass-like, but there before it turns to glass, it can still be solidified. So
Mm.
it doesn't have to vitrify. You don't have to have vitrification to say, therefore it's a fulgurite. I mean,
Ah,
unless your definition of a fulgurite is vitrification. If it's not, if you can just say it freezes in place,
mm.
then you've got a fulgurite. And that's what I think Fantasy Canyon is. Because there's not vitrification that I found in there, but is it frozen in place and hardened? Oh yeah. Oh yeah.
And and the sidewalls are blackened.
The sidewalls are blackened. That's another one. You've got desert varnish, which is this, it is kind of blackened. In fact, I'm not
Yeah,
sure that desert varnish and your blackening of the canyon walls aren't the same thing. I think they are.
I believe they are.
But
Yeah.
this is like duh obvious. If you take a voltage, you can step it up and have different effects
Yeah.
and step it down. And that's, in nature, there's not really, aside from the sun and the transistor action that Don Scott has talked about, there's not really any limits on what magnitude of voltage and amperage happens in a particular area.
Yeah, there's no rectifiers, there's no diodes, nobody's pointing anything at anything. You
Exactly.
know, you're not, yeah, no diodes.
E-
So it
Exactly.
can change direction at will.
And I think that's what we saw with all of the videos we just finished watching, is you would see different effects happening all of a sudden in different directions. You're like, oh wow, that's interesting. It wasn't just everything moved to the right, everything moved to the left. It was, oh, right, left, up, down,
Vortices.
vortices.
Yeah.
Exactly.
Spinning,
Everybody
lots
take
of
off,
spinning.
everybody come
Yeah.
together.
Lots of
All of that.
spinning, lots of pulling, lots of pushing, lots of bulldozer action,
Yeah.
you know,
Uh,
entrenching tools.
all of that. Okay, Steve, I'm gonna call this good because I've got clients calling my phone right or texting me right now. But
Okay.
let's do this again and go over the next few videos that you have. Because you said you got four more.
Yes.
Let's do that in a day or two.
Okay. Suit yourself when you want to do it.
I'll just call you when I get a free moment. Just think like Monday or Tuesday. We'll probably do
Yeah,
it
send
again.
me a text.
Oh, we'll do that. All right. Enjoy the rest of your weekend.
You too.
Take care. Bye-bye.